Welcome to Section 3. In this section, you look at some of the AWS services and open source tools for information extraction. Amazon Comprehend provides a number of asynchronous jobs through the API for tasks such as sentiment analysis, language detection, and topic modeling. A number of the service's capabilities are relevant for the general information extraction. First, the service can help detect textual references to entities, such as the names of people, places, and things. Next, Amazon Comprehend can help to analyze documents to detect specific types of events. Examples include mergers and bankruptcies. The service can also help to find key phrases such as good morning in a document. Amazon Comprehend can also help to analyze documents to detect personally identifiable information, called PII. This is data that could be used to identify an individual, such as an address, bank account number, or phone number. Finally, the service can parse the words in your text to show the speech syntax for each word. This can help you understand the document's content. You can run these jobs against your documents without much data preparation or knowledge of machine learning. However, you do need some knowledge of how to handle the returned data to understand and use the results. Before you can start a job, you need to prepare your data. You can store data in a single file with one document per line, or each document in its own file. Regardless, each document has a maximum size of 102,400 bytes, and it must be in UTF-8 format. You need to store the input files in a bucket in Amazon Simple Storage Service or Amazon S3. To start a job that is asynchronous, use the Start Entities Detection Job function. To manage your jobs, use the function for listing called List Entities Detection Jobs, and for describing, call Describe Entities Detection Job. Once the job is complete, the results are output to the S3 bucket you specified. The example on the slide shows the output. Begin offset and end offset specify the start and end characters of the entity. Score is the confidence level that Amazon Comprehend attaches to the entity. Text is the actual entity that was found. Type indicates the type of entity that was found, such as person or location. With Amazon Comprehend, you can also train a custom entity recognizer, rather than being limited to the available entity types. If you have sufficient data to train effectively, you can identify almost any type of entity. You can provide your data to Amazon Comprehend in two ways. With annotations, you provide the location of your entities in a large number of documents so that Amazon Comprehend can train on both the entity and its context. With Entity List, you can provide limited context. This method only uses a list of the specific entities so that Amazon Comprehend can train to identify the custom entity. When using annotations to train a custom entity recognizer, you must provide annotated training data. Annotations label entities in context by associating your custom entity types with the locations where they occur in your training documents. You can provide this training data as a comma-separated values or CSV file. The slide shows 4 lines from an example training file where a person's name is the entity. The first line is Anna Carolina Silva is an engineer in the high-tech industry. So the entity for this line is Anna Carolina Silva. The table shows the annotation data for the file. The annotation has the line number, the start and end characters where the entity is found, and the type of entity. Look at the annotation for the first line, line 0. The entity Anna Carolina's name begins at character 0 and ends at character 18. Engineer is the entity type. Note that the third line from the training file isn't listed in the table. That's because the line doesn't have an entity of interest. Jorge is a judge, not an engineer or manager. Building a large annotated training document can be complex. You can use Amazon SageMaker Ground Truth to label the data set you need to train an Amazon Comprehend custom entity recognizer. Ground Truth provides built-in labeling workflows that take you step by step through tasks. The workflows also provide tools to efficiently and accurately build the annotated NER datasets required for Amazon Comprehend. The diagram on the slide shows the end-to-end process. First, you upload a set of text files to create Amazon S3. Then you create a private work team and an NER labeling job in Ground Truth. Next, the private work team labels all the text documents. When that is complete, Ground Truth creates an augmented manifest called Manifest in Amazon S3. Next, an AWS Lambda function parses the output manifest to create the annotations and documents in a CSV file, which Amazon Comprehend requires. Finally, on the Amazon Comprehend console, you launch a custom NER training job using the dataset generated in Step 4. When using an entity list for custom entity recognition, you need to supply a CSV file with only 2 columns. The first column contains the text of an entry example as it is written in the document corpus. The second column gives the entity type, which you define. The entity type must be uppercase with underscores in place of spaces. For example, senior_manager. You can train up to 25 entity types per model. The slide shows the example training data from a previous slide. Again, the entity is a person's name. The table shows the entity list for this data. Look at the first row. The first column has the entity text, Anna Carolina Silva. The second column gives the entity type, engineer. Again, the third line from the training file isn't included in the entity list. That's because the line doesn't have an entity of interest. Note that you need a minimum of 200 entity matches per entity in the entity list to train a model for custom entity recognition. spaCy features a statistical entity recognition system, which assigns labels to contiguous spans of tokens. The default train pipelines can identify a variety of named and numeric entities, including companies, locations, organizations, and products. Entity identification can only be as good as the data used to train the model. You might need to use your own labeled dataset to train the model, especially for domain-specific terms. To update an existing model, you need a few hundred to a few thousand examples. For a new category, you need a few thousand to hundreds of thousands. It can be time-consuming to create these training sets, and it requires human annotators. In the example on the slide, the code first loads a pre-trained model named EN-Core WebSM and initializes the NLP object with the text. This returns a doc object. You can iterate through the ENTS property of the doc object to display the entities. spaCy also contains a visualizer named DisplayC, which is useful for learning and troubleshooting. In this section, you learned about the information extraction capabilities that Amazon Comprehend provides. These require minimal machine learning knowledge. You also looked at how to extend the pre-trained models using your own annotations or entity list. You also learned about spaCy, which is one of many third-party packages that provide functions for IE tasks. Thanks for completing this module. In the next module, you'll learn about topic modeling. See you in the next video.